Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the seventh planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the third largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus. Something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one. And if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see. If you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset, though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover.
This star is in its T-Tauri phase. It's surrounded by a giant donut-shaped disk of dust and gas circles. Most of the material in the disk falls back onto the star, but some dust particles crash into one another. If the collision is relatively gentle, they clump into much larger objects. At first, these objects are no larger than the width of a strand of human hair. With time, dust clumps turn into pebbles. Pebbles become large rocks. The gas helps these rocks stick together, and while some of the bigger objects break apart, most of them turn into the building blocks of future planets, planetesimals. While orbiting the star, the planetesimals clear all the material away from their path. All that is left behind is just some fine dust. Billions of years later, the disk surrounding the star completely transforms. It's now colder and farther away from the heat of its parent star. The water it contains can finally freeze, and tiny particles of ice are now traveling around the star along with the dust. With time, they form snowballs that later turn into giant planetary cores. And since these regions of space are colder, gas molecules there slow down and get drawn into this core. Astronomers believe that's how gas giants like Jupiter, Saturn, Uranus, or Neptune are formed. Interestingly, Jupiter and Saturn were the first planets to form in the solar system. It took them a mere 10 million years or so. Closer to the star, other planets begin to appear. Those are rocky planets like Mercury, Venus, Earth, and Mars. Such space bodies can take tens of millions of years to form after their star is born. After planets start orbiting their star, they are referred to as a planetary system. This system can consist of one or several planets and include natural satellites, asteroids, dwarf planets, meteoroids, and comets. The Sun and the 8 planets orbiting it are known as the Solar System. The closest planet to the Sun is Mercury. The place looks eerily similar to the Moon, Earth's natural satellite. But from up close, it becomes clear that it's just an illusion. Mercury is one of the 4 rocky planets of the Solar System. It has a solid surface. All over the place there are craters created by space rocks. Mercury is the smallest of all the 4 inner planets. It's just 3,000 miles at the equator. If you decided to see the entire Mercury, it would take you about 2.5 days to drive all the way around the planet. That is, if you were driving your car at a speed of 50 miles per hour without stopping. But driving there wouldn't be a simple task. The planet's surface is littered with gigantic hills with steep slopes. Some of them reach a height of 2 miles. Mercury doesn't have an atmosphere, and the temperatures on the planet are extreme. 800 degrees Fahrenheit during the day and minus 290 degrees at night. It's also the second densest planet in the solar system, topped only by Earth. Mercury has a massive metallic core. It takes up almost 85% of the planet's volume. The core alone contains more iron than any other planet of the solar system. Not so long ago, astronomers discovered that Mercury might have not only the outer core, which consists of liquid metal, but also a solid inner core. The planet's outer shell is composed of a rocky mantle and solid crust, which is just 300 to 400 miles thick. Instead of an atmosphere, Mercury has a thin exosphere. It's made up of mostly oxygen, sodium, hydrogen, helium, and potassium. But the planet is too close to the Sun. That's why the solar wind and striking meteoroids keep sweeping away the atoms of this exosphere. Now, Venus is very different from the bluish planet you might have seen in pictures. It's surrounded by a super-dense atmosphere made up of carbon dioxide. If you decided to land on the planet's surface, you'd have an opportunity to observe thick clouds of sulfuric acid pass by. By the way, if you need a drink on Venus, be sure to only drink H2O. If you drink H2O too, well, that'll be your last drink. The planet's surface is actually reddish-brown. Venus is a dry and hot place, with a pressure 90 times greater than that on Earth. Flat, smooth plains cover 2/3 of the planet's surface. But there are also large mountains. Those are volcanoes. Most of them are extinct, but some might still be active. Venus has 2 vast highland areas the size of South America and Australia, and several expansive lowlands. There are also long, winding canals. They're old lava flows, and some of them reach 3,000 miles in length. The planet's dense atmosphere creates a greenhouse effect, similar to that on Earth. It traps heat, and temperatures on Venus rise up to 880 degrees Fahrenheit. That's hot enough to melt lead. The pressure on the planet's surface is the same as at a depth of 3,000 feet underwater on Earth, crushing. The planet's metallic iron core is 2,400 miles wide. That's almost as much as the distance from New York to Los Angeles. The next layer is a molten rocky mantle that's 1,200 miles thick. Venus's insides are covered with a crust. It consists mostly of basalt and is 6 to 12 miles wide. The planet's thick atmosphere is nightmarish. It's 96% of carbon dioxide with 3% of nitrogen and thick clouds of sulfuric acid. Earth is the 3rd planet from the Sun. From space, it looks like a blue marble with areas of green, yellow, brown, and white swirls. All that blue area is water. It covers 71% of our planet's surface. Even from up there, you'd spot the Great Barrier Reef near the shores of Australia. It stretches for 1,600 miles. That's more than the distance from Boston to Miami. From space, you could also see all the 277 miles of the Grand Canyon at once. Earth is the densest planet in the solar system. At its center, there's a core that takes up 15% of the planet's volume. The core consists of two parts, the outer and inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles. That's 20% of the entire Earth's radius, or 70% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also contains iron and nickel, but it's not under enough pressure to be solid. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the Sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. The mantle surrounds the outer core. This layer is about 1,800 miles thick and makes nearly 84% of the entire Earth's volume. It consists of silicate rocks rich in iron and magnesium. The crust is a relatively thin layer that takes up only 1% of the Earth's volume. Along with the upper part of the mantle, it's broken into tectonic plates. They move as fast as your fingernails grow and let heat escape from the Earth's interior. The crust is mostly made up of oxygen, silicon, aluminum, iron, and other minerals. The fourth planet from the Sun is Mars. It's the last of the inner planets. They're also called terrestrial, since they're made up of rocks and metals. This place is freezing cold. The temperatures here drop down to minus 80 degrees Fahrenheit. Even from afar, the planet looks reddish. It's mostly because the ground there is covered with rusty-colored dust. The same fine dust is floating in the air. Mars is full of colors: golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places it's 7 feet thick. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The tallest planetary mountain in the solar system, Olympus Mons, is on Mars. It's 2.5 times higher than Mount Everest and about the size of Arizona if you stretched a tape measure across it. Martian atmosphere is much thinner than Earth's and contains 95% carbon dioxide and a mere 1% of oxygen. Dust storms sometimes cover the entire planet, and the largest ones can even be seen from Earth. Mars has a core that's made mostly of iron, nickel, and sulfur. It's between 900 and 1,200 miles wide. The core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. The mantle surrounding the core is composed of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1,100 miles thick. The thin planet's crust consists of volcanic basalt rock. Astronomers think it isn't broken into tectonic plates and remains in one piece. The crust is covered with fine reddish dust that looks like talcum powder. Moving on, Jupiter is the largest planet in the solar system. It's more than 89,000 miles wide at the equator. Jupiter is so huge it could fit 1,300 Earths inside it. It's also terrifyingly hot, about 43,000 degrees at the core. It's impossible to land on the planet. Jupiter is a gas giant with an atmosphere made up of hydrogen and helium gas. It's hidden away by a layer of thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. One of the most unusual phenomena on Jupiter is the Great Red Spot. That's an enormous spinning storm the size of our home planet. It's been raging for the last 360 years. The hurricane's color varies from pale salmon and white to dark brick red. It's extremely windy on Jupiter, with wind speeds ranging from 200 to 400 miles per hour. Like I said, Jupiter is a gas giant. If the planet was 80 times as massive as it is now, it would have a chance to turn into a tiny red dwarf star. It's still unclear whether the planet's core is a molten ball of liquid or a solid rock 14 to 18 times the mass of Earth. There's even some evidence that the gas giant's core might be melting right at this moment. Whatever the truth is, the temperatures at the center of Jupiter reach 63,000 degrees. Around 90% of the planet's atmosphere is hydrogen. The remaining 10% is made up of helium with tiny traces of other gases. Under immense atmospheric pressure, hydrogen and helium gases turn into a dense fluid. Closer to the core, this liquid becomes a mixture of metallic hydrogen and helium. Since there's no solid ground on the planet, astronomers define the planet's surface as the point where the atmospheric pressure equals that on Earth. You wouldn't be able to stand on that surface, though. It's just another layer of gases. But the gravitational pull there is more than 2.5 times more powerful than on our planet. Now, like Jupiter, Saturn doesn't have any solid surface. This planet's made up of mostly hydrogen and helium. If you visited it, you would notice that the temperature and density on Saturn change the deeper you go. If you wanted to step on Saturn's surface, you just fall into the planet. Its gravity is similar to that on Earth, and the density at the surface is very low. That's why you'd free fall until the ever-increasing pressure crushed you. Now, from above, it looks as if the gas giant does have a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. The visible outer layer is ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Saturn is an extremely windy place. Wind speeds here reach 1,100 miles per hour at the equator. For comparison, the fastest wind speeds on Earth don't exceed 250 miles per hour. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure is. At some point, it makes hydrogen turn into a liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core with hydrogen and helium surrounding it. On the other hand, even if it's made up of rocky material, the core can still be liquid. One of the most recognizable features of Saturn is its awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. Saturn also has 53 confirmed and named moons. Another 29 moons are still awaiting confirmation of discovery and official names. Titan, an icy world bigger than our moon and even Mercury, is the largest of Saturn's moons. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. If you found a pool of water huge enough to fit the ringed planet, it would float on the surface. And still, because of its large volume, the planet is 95 times more massive than Earth. Out further, a blue-green ball of ice and gas 1.7 billion miles away from the Sun is Uranus. This ice giant has such a beautiful hue thanks to the light from the Sun. It gets reflected off the planet's surface. The planet isn't solid. If a small asteroid collided with Uranus, it would simply fly through the upper atmosphere and sink into the icy liquid center. Now, Uranus orbits the Sun on its side. It's the only planet with its axis pointing almost directly at our star. It might be because of a collision with a large space body soon after the formation of the planet. In summer, extreme storms shake the planet. Such hurricanes only occur when Uranus is heated to its most. A hurricane can sometimes spread for over 6,000 miles. That's almost the distance between Japan and the US. The planet has 2 sets of rings. The inner system consists of 9 narrow dark rings, and the outer rings are bright, one blue and one red. At the very center of Uranus, there's a rocky core. It's small, just half of Earth's mass. Compared to other planets, Uranus's core is rather cool, a mere 9,000 degrees. An ice mantle surrounds the solid core. It takes about 80% of the planet's volume. It's not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia ice, and methane. Sometimes it gets referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium. The planet looks blue-green because of methane gas that absorbs the red light. Now, the farthest planet from the Sun, Neptune, is only 4 times the size of Earth, but 17 times as heavy. The blue surface you see in pictures is actually a layer of swirling gas and permanent clouds. The planet's mantle, which is made up of water, ammonia, and methane ices, is the closest thing Neptune has to a surface. And still, this surface isn't solid. If you made a decision to get down to the very core of the planet, you'd feel great temperature changes. It would vary from minus 340 degrees at the surface to more than 12,000 degrees at the core. Such mind-boggling temperature differences create powerful storms whose speeds reach 1,200 miles per hour. No wonder Neptune is considered the windiest planet in the solar system. Like Uranus, Neptune is an ice giant. The planet's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times greater than that of Earth. Astronomers also believe that at a depth of 6,200 miles, there might be a layer where it rains diamond crystals. The planet's core is surrounded by a large mantle. It's a superheated region of liquid with temperatures as high as 3,000 to 8,500 degrees Fahrenheit. The mantle is rich in methane, ammonia, and water, and equals up to 15 of Earth's masses. Neptune's atmosphere forms 5 to 10% of the planet's mass. It stretches 20% of the way down to Neptune's core. The atmosphere consists of 80% hydrogen, 19% helium, and a bit of methane gas. The methane gas is what gives the planet its bluish hue. But what do planets look like outside our solar system? Are they the same as our rocky worlds and gas giants? Well, some of them are pretty bizarre. We're now 40 light-years away from Earth, near an exoplanet called GJ 1214b. By the way, an exoplanet is any planet outside the solar system. It's about 3 times the size of our planet, but its mass is 8 times that of Earth. Once every 38 Earth hours, GJ 1214b orbits a red dwarf star. The temperatures on the surface of the planet are literally toasty, around 400 degrees Fahrenheit. But that's not the only thing that makes this planet so unusual. After observing this distant world through the Hubble Space Telescope, astronomers have calculated that GJ 1214b is a giant water world. It's encapsulated by a steamy and dense atmosphere. There's no other planet like that known to people. Because of the high pressure and high temperatures on the surface of the planet, such exotic materials as superfluid water and hot ice might have formed there. Meanwhile, this bright blue exoplanet is located 62 light-years away from Earth. It looks peaceful and slightly familiar. It's a bit larger than Jupiter, and its bluish color might remind you of our home planet. But this pretty appearance hides the planet's terrifying nature. Its beautiful hue comes from silicate atoms and particles that make up the planet's atmosphere. At the same time, the wind speeds there can reach a terrifying 5,400 miles per hour. That's 7 times the speed of sound. Temperatures on the planet are also extreme, over 1,600 degrees. But even this is not the worst. It rains glass, sideways, in this scorching hot world. If such a storm happened at the equator on Earth, it would only need around 5 hours to travel around the planet and destroy everything in its path. Several years ago, astronomers discovered a planet as large as Neptune, and it orbits a star that's no bigger than Earth. That's a truly strange setup, since usually stars are way bigger than the planets traveling around them. What might explain this phenomenon is that the star we're talking about is not so much of a star anymore. It's a teeny white dwarf with a very tricky name. This dwarf is more of a stellar skeleton. It can't fuse elements within its core, which could prevent it from gravitational collapse. These days, it's a highly compressed, smoldering space body with an insane temperature of 49,500 degrees. In other words, the star is so hot that it's slowly vaporizing the nearby planet. Because of this insane heat, the planet is losing its atmosphere. The white-hot star is sending streams of vaporized material far away from the planet at a rate of about 260 million tons a day. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. It's located 30 light-years away from Earth in the constellation of Leo. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. The distance between them is 15 times smaller than the distance between Mercury and the Sun. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, and it remains solid despite blistering temperatures. One of the most plausible explanations for this phenomenon is the incredibly strong gravity on the planet. It compresses the trace amounts of water vapor in the atmosphere into ice and then stops it from melting. Now, about 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is 5 times the size of Earth. It needs only 2 hours and 10 minutes to orbit its parent star, which is a pulsar rotating 10,000 times in a minute. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline, meaning that at least some part of the planet is diamond. Now, look at this hot Jupiter. That's the name used to describe planets orbiting their home stars uncomfortably close. On WASP 76b, it rains iron at night. As for the daytime side of this planet, the temperatures there rise up to 4,300 degrees. That's hot enough to vaporize metal. The bizarre planet is just a bit smaller than Jupiter. It's located 640 light-years away from our home planet. The terrifying weather conditions in this world are caused by its extreme orbit. WASP 76b is 10 times closer to its parent star than Mercury is to the Sun. It makes this star and the huge planet tidally locked. One of the sides of WASP 76b is always baking in the heat coming from the star, and eternal night reigns on the other side. Now, a mere 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way. This planet doesn't have a star of its own, but this nomadic world has an insanely powerful magnetic field. According to a 2018 study, it's 4 million times stronger than Earth's magnetic field. The exponent, with a long and complicated name, also produces amazing auroras. When SIMP was first discovered in 2016, astronomers thought they had spotted a brown dwarf. That's an object that's too large to be a planet and too small to be a star. But another study proved that the thing was small enough to be considered a planet. Of course, this planet is a mammoth among its peers. It's 1.2 times the radius of the largest planet of the solar system, Jupiter, and more than 12 times its mass. Astronomers say that the exceptionally powerful magnetic field helps the planet produce such stunning auroras, but they are generated in a different way than auroras on Earth. The scientists claim SIMP's moon might help the planet create its light shows. This planet is nothing like you've seen before. It's often referred to as a super Saturn or Saturn on steroids, all because J1407b has a huge system of rings. They're 640 times larger than those on Saturn. This exoplanet sits 434 light-years away from Earth. It's the only known world with rings similar to those on Saturn. If J1407b ever swapped places with Saturn, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. Gliese 581c is located 20 light-years away from Earth in the constellation of Libra. It orbits its home star at a distance that is a mere 7% of the 93 million miles that separate Earth from the Sun. Gliese 581c is tidally locked with its star. It means that one of its sides always faces the star, and the other is plunged into endless darkness. Of the sunny side, the temperatures are insanely high, and the dark side is freezing. But between these two extreme areas, there's a narrow zone with the conditions that could potentially support life. And how about visiting a planet where it might rain sapphires and rubies? Hat P7b is a pretty far away place. The planet sits more than 1,000 light-years away from Earth. On its night side, the atmosphere contains a lot of aluminum oxide, also called corundum, and corundum gems are sapphires and rubies. Astronomers think there might be powerful storms on the planet when it literally rains rubies and sapphires. That's why these gems might be scattered all over the planet. There's also a planet that eats up light. It's called WASP 12b. It's one of the darkest exoplanets we know about. That's because its day side consumes light rather than reflects it back into space. The planet is enormous, twice the size of Jupiter, and it traps more than 94% of the light falling into its atmosphere. This might be the reason for the insane temperatures there, 4,600 degrees Fahrenheit. WASP 12b travels so close to its parent star that it completes one orbit within a day. Its night side is twice as cool as the day side, a mere 2,200 degrees. But thanks to this difference in temperature, water vapor and clouds form above the surface of the planet, and then swirls of material from WASP 12b's superheated atmosphere spill onto its star. Now, see that jaw-dropping magenta-colored exoplanet? It's located in the constellation of Virgo. It's called Gliese 504b. The distance between this planet and its home star is 9 times the distance between the Sun and Jupiter. The planet is relatively newly formed. It's still glowing with heat. That's what makes its surface look pink. We've traveled 20,000 light-years and reached a red dwarf in the Sagittarius constellation. Far away from this cold star, there is a planet with another long and tricky name I'm not going to attempt. This world is so far away from its parent star that it receives very little heat. It's one of the coldest planets we know about. Its surface temperature is lower than minus 360 degrees. That's why the entire planet is encased in a thick layer of ice. If you stepped on its surface, you'd see nothing but glaciers, vast plains, canyons, and mountains of ice. And still, astronomers think life could exist deep beneath the chillingly cold frozen surface. The planet's core might generate enough heat to melt some of the inner ice. If it's true, then there can be an enormous subsurface ocean on the planet. Earth. Home. The third blue rock from the Sun, the only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like a average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles and chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot. a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet but looks like the Moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Caloris Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, the desert will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, but it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, it's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and trading. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be two dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're going to need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on, but the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon, but scientists are already discussing moving to other planets to find a new home for humans.
Our solar system might have some more planets up its sleeve. We know about 8 official planets, but they're not the only ones that survived the chaotic formation of our solar system 4.5 billion years ago. Astronomers say there are 3 categories of planets in our solar system. We're in the first one, the 4 rocky inner planets, Mercury, Venus, Earth, and Mars, that peacefully orbit the Sun. They're located within the main asteroid belt that separates Mars from Jupiter, which is in category number 2. That one's a group of planets in the outer solar system, the gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets have huge amounts of ice and gas around what scientists believe to be their rocky cores. The third group lies beyond the area where our local planets are, somewhere further than Neptune. It's the realm where you'll find dwarf planets such as Pluto, Eris, and Sedna, and many smaller space bodies like comets. But new findings say there could be something else lurking in the dark, besides dwarf planets and tiny space bodies. Maybe even a new planet. Models scientists made say that our solar system used to have 1 or more rocky planets, the size of Mars or Earth. Over time, these rocky wanderers interacted with the wide gravity fields of our gas giants. This kicked them into a far-out orbit, away from the neighborhood. The question is, if one of those Mars-sized planets survived and could really be somewhere out there. Scientists have made simulations to see what potentially happened. These showed that in half of such cases where planets interact with the gravity of gas giants, they get ejected into interstellar space. In the remaining half, there's this one rogue planet left in an orbit similar to the ones the Kuiper Belt objects are following. There's only one thing left to do now: find it. Astronomers found the loneliest planet in the universe. They were trying to find distant brown dwarf stars, or failed stars, ones that never become massive enough to start shining. Stars are born with big masses, which means they also have strong self-gravity. The star squeezes in on itself. That causes high internal temperatures and enables the star to shine. But instead, they found a lonely wanderer, CFBD SIR 2149. The planet is between 50 and 120 million years old and has a surface temperature of 750 degrees Fahrenheit. Compared to stars, that's cold. At first, scientists thought it could be a brown dwarf star, but in that case, it would be way older. This starless planet floats around through space, passing only 130 light-years away from our planet. Our galaxy, the Milky Way, is 100,000 light-years wide, so that's relatively close. The lonely traveler is actually a gas giant, 4 to 7 times bigger than Jupiter. Maybe it was kicked out from its own solar system because of gravitational forces, or getting into another planet's orbit, or it was formed away from its parent star. Far beyond Pluto, on the edge of our solar system, there's a space body about as big as Pluto, but a little bit colder and way denser. It's probably a big rocky body covered in a thin icy mantle. It's the dwarf planet Eris. Both Pluto and Eris occupy the Kuiper Belt, which is the distant ring of frigid space bodies that lies beyond Neptune. A day there lasts 25.9 hours, pretty similar to Earth. But Eris circles our sun in the distance 3 times farther than Pluto, which means its year is pretty long, 557 Earth years. Eris has a bright, icy surface. It's one of the most reflective bodies in our solar system. It bounces back more than 95% of the light that strikes it. Somewhere out there, even farther, there's a super Saturn, J1407b, much larger than Jupiter or Saturn. It's an exoplanet, which means a planet that orbits a star other than our Sun. Super Saturn is 434 light-years away from Earth in the constellation of Centaurus. It's the only exoplanet we know about with rings similar to Saturn. It actually has a huge ring system, 200 times bigger than Saturn's rings. There are more than 30 rings, each of them tens of millions of miles in diameter. There are gaps in the rings, which means there could be some interesting satellites, exomoons, around. If this super Saturn could swap places with our regular Saturn, its rings would absolutely dominate our sky. You could look up and easily see them. The view would be amazing because they would appear much bigger than a full moon. Scientists have found thousands of planets outside of our solar system. Some are dense as iron, while others are airy and light. And then there's the water world, GJ1214b, a steamy world, bigger than Earth and smaller than Uranus, 40 light-years away from us, in the constellation of Ophiuchus. It's a watery planet surrounded by a thick atmosphere, 2.7 times Earth's diameter, and almost 7 times heavier than our home planet. It was most likely formed somewhere farther from its star, where there was plenty of water ice, but later migrated to where it is today. Its surface temperature is 440 degrees Fahrenheit, which is too hot to host life like on Earth. It also has much less rock and much more water than our planet. Imagine a planet with no land, but only endless oceans covering all of its surface. High pressures and temperatures would form things like superfluid water or hot ice, some pretty exotic materials that we can't see on our planet. Gliese 436b. It's a Neptune-sized exoplanet 30 light-years away from our planet in the constellation of Leo. It makes one full orbit around its star in a little more than 2 days. This planet defies the laws of physics. It orbits its star, Gliese 436, which is smaller, cooler, and less luminous than our Sun, at a distance 15 times closer than Mercury is to the Sun. When we typically think of ice, we picture a frozen cube. But this planet has an icy surface, even though the temperature there is 980 degrees Fahrenheit. This temperature is way above the melting point, but the ice remains solid and burning hot. This happens because of very strong gravity. It compresses the water vapor in the atmosphere into solid ice. The pressure here doesn't allow the ice to melt, no matter how hot the surface is. Now imagine being on a mysterious planet and it suddenly starts raining sapphires and rubies. One distant exoplanet, HAT P7b, a gas giant 1,000 light-years away from Earth in the constellation of Cygnus and 16 times bigger, has specific weather and pretty violent storms. Rubies and sapphires are scattered across the planet when it's raining. On the planet's night side, there's a high amount of corundum in the atmosphere. And corundum is what mineral gems such as sapphires and rubies are made of. Clouds of corundum give such an amazing view. The planet is plagued by severe winds that often turn into powerful storms that push huge masses of those clouds across the planet. Although the planet is uninhabitable, it would certainly be cool to come there and pick up some gems. Still, the weather is pretty wild. Plus, the temperatures are over 4,600 degrees Fahrenheit. By comparison, Venus is the hottest planet in our solar system, and its temperature is only 900 degrees Fahrenheit. Looking over the expanse of space, you can see a beautiful little blue dot in the endless darkness. It's an exoplanet, HD 189733b, that lies 63 light-years from us in the constellation of Vulpecula. But it's way hotter and larger than our planet, around the size of Jupiter, and it completes its orbit around its host star in only 2.2 Earth days. That orbit is so close that the planet is most likely tidally locked. That means it's always showing only one face to its star, like our moon always shows one side to Earth. The weather here is crazy. The winds blow at up to 5,400 miles per hour, which is 7 times the speed of sound. The fastest wind on Earth only hit the mark of 230 miles per hour. And it gets better. The rain here is not made of water, but of molten glass. Clouds are made of silicate atoms and particles. They are the key element that gives the planet its cobalt blue color, not the reflection of oceans, which is the case with Earth. Earth used to be purple. Today, even when you look at our planet from space, you see a lot of green. The green we see in nature is there because of photosynthesis, the process where plants transform energy coming from the sun into energy they need to live and to produce oxygen for us. The main part of the process that gives plants the green color is the chlorophyll pigment. A long time ago, instead of chlorophyll, there was a molecule called retinol. Its pigments absorb yellow and green light and turn it into red and blue, so the Earth was more purple. And then there's a pink planet, GJ 504b, far away from us, in the Virgo constellation, 4 times more massive than Jupiter. It's a newly formed exoplanet, around 160 million years old. By comparison, the Earth is 4.5 billion years old. If we could go there, we would see an incredible world that glows from the heat of its formation. Everything around you would be colored magenta.
How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of 2 more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaetons was a good story, it's not popular anymore.
Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the Sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our Sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our Sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the Sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star, while the other side remains in perpetual darkness. So one side is always very hot, while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620 26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star. Not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
Mercury gets a bad rap for always being hot, but that's not entirely true. The planet's got no atmosphere, so its temperature swings are wild. When it's facing the sun, it can get up to a blistering 800 degree Fahrenheit, but when it's turned away, it drops to a frigid minus 290 degrees. The reason for this is that Earth has a cozy atmosphere that keeps our temps in check. Mercury doesn't have that luxury, so it's at the mercy of the sun's rays. But despite all that, Mercury's still worth checking out. It's close to the sun, which makes it a prime spot for studying how solar radiation affects planets. And even though it's not exactly hospitable to life, there are still plenty of mysteries to unravel. Venus is often referred to as the sister planet of Earth. Yeah, many people believe that it's this beautiful and lush planet, just like our home. But boy, are they wrong. In reality, Venus is a total diva. She's got this thick atmosphere that traps heat and causes surface temperatures to reach up to a scorching 864 degrees Fahrenheit. I mean, I get it. Venus wants to stand out and be unique, but she's taken it to a whole new level. She's like that one friend who always has to one-up everyone else. Oh, you think Earth is cool? Well, I'm the only planet that spins clockwise? Beat that. But let's be real here. Venus is just trying too hard. She's got these crazy sulfuric acid clouds that rain down on her surface and make it impossible for anything to survive. It's like she's trying to keep all the attention for herself by making sure no other life forms can exist. And her atmosphere, it's so thick and heavy that it would crush us like a grape. So, yeah, Venus may look pretty from afar with her bright yellowish glow, but don't fall for that. She's a total drama queen who just can't handle sharing the spotlight with anyone else. Anyway, enough about Venus. Let's focus on the real star of the show, Earth. We may not have all the flashy features that Venus has, but at least we're hospitable and welcoming to all forms of life. Plus, we've got pizza. So who needs sulfuric acid clouds anyway? You may think that since we live on this planet, we know it from A to Z, and there is no room for any misconception. Alrighty, then tell me, what shape is Earth? If you say it's round, sorry, but you're not right. So, our planet may look like a ball, but it isn't a perfect one. You see, because of the spinning action, the North and South poles get squished a bit and they're sort of flat. The Earth's wobbling, and other stuff are actually causing it to change shape over time, but it's still roundish. Let's talk about Mars, the red planet that has fascinated humans for centuries. Now, I know we all have this idea that Mars is this habitable planet that we can just pack our bags and move to if Earth becomes uninhabitable. Nope, that's not entirely true. One common misconception about Mars is that it has a breathable atmosphere. While Mars does have an atmosphere, it is much thinner than Earth's and consists mostly of carbon dioxide, making it unsuitable for human life without extensive life support systems. So if you're planning on taking a stroll on the surface of Mars, you better pack your oxygen tanks. But hey, that doesn't mean we should give up on our dreams of colonizing Mars. Who knows? Maybe in a few decades, we'll be able to call Mars our second home. Some people think Jupiter is a solid planet, but let me tell you, that's just a bunch of hot air. Literally. Jupiter is actually a gas giant made up mostly of hydrogen and helium. It's so massive that it doesn't even have a solid surface. I mean, I thought my bed was soft, but floating on a cloud of gas sounds pretty comfy too. Jupiter's atmosphere gradually transitions into its interior, which means it's like a never-ending party in there. Saturn's rings are one of the most fascinating features of the planet. So, a common misconception about Saturn is that its rings are solid. In reality, Saturn's rings are made up of countless small particles of ice and rock that orbit the planet. They stretch out over 174,000 miles from the planet's surface, but are only about 65 feet thick. The particles that make up the rings range in size from tiny specks of dust to large boulders. Scientists believe that the rings were formed from debris left over after the formation of Saturn and its moons. Over time, the particles were pulled in by Saturn's gravity and formed into the beautiful rings we see today. Saturn's rings also have some amazing features, such as gaps and divisions caused by the gravitational pull of nearby moons. There are also waves and spiral patterns that are created by the gravitational interactions between the particles in the rings. Despite their beauty, Saturn's rings are constantly changing. The particles collide with each other, creating new ones and breaking apart others. This means that the rings we see today may look very different in the future. So next time you look up at Saturn and its rings, remember that you're looking at a cosmic snow globe made up of billions of tiny particles floating around the planet. Now, one common misconception about Uranus is that it's a lazy dude who can't even rotate properly. People think it just rolls around on its side all day long, but let me tell you, that's not entirely true. Sure, Uranus does have a tilted axis of rotation, but it still manages to spin in the same direction as most other planets in our solar system. It's like that one friend who always shows up late to the party, but still manages to have a good time and fit in with the crowd. But let's be real, Uranus is still a bit of an oddball. It's the only planet in our solar system that rotates on its side to such a degree. But after all, variety is the spice of life, right? So cheers to Uranus, the planet that refuses to conform to anyone's expectations. Ugh, I wish I had the guts to be like this. Have you ever heard someone say that Neptune is just a blue version of Jupiter or Saturn? Well, let me tell you, that's like saying a banana is just a yellow version of a cucumber. It's not even close. Sure, Neptune and its gas giant buddies share some similarities, but Neptune stands out in the crowd with its beautiful blue hue. It's all thanks to the methane chilling in its atmosphere. By the way, did you know that it's the farthest planet from the Sun? It's so far out there that it takes almost 165 Earth years for it to complete one orbit around the Sun. Talk about taking your sweet time. And let's not forget about its 14 moons. That's right, Neptune has a whole entourage of moons following it around like groupies at a concert. Maybe they're hoping to catch a glimpse of Neptune's famous blue glow. So, next time someone tries to tell you that Neptune is just a knockoff version of Jupiter or Saturn, you can confidently correct them and say, "Excuse me, but Neptune is its own unique gas giant with a fancy blue vibe." Did you know that Pluto isn't actually considered a planet anymore? That's right, in 2006, the International Astronomical Union decided to reclassify Pluto as a dwarf planet. So what exactly does that mean? Well, a dwarf planet is a celestial body that orbits the Sun and is big enough to be rounded by its own gravity. But it hasn't cleared its orbit of other debris. It's a common misconception that Pluto is still considered a planet, but the truth is that it's just not big enough to make the cut. Sorry, Pluto. Don't worry though, you may be small, but you're still loved by many. Plus, being a dwarf planet is pretty cool too. You get to hang out with other celestial misfits like Ceres and Haumea. So keep on orbiting, Pluto. We still think you're out of this world.
Tired of waiting for colonization? Does the Earth seem way too boring with all its problems and mosquitoes? Well, have no fear. It's time to take matters into your own hands and build your own planet. But before you start reaching for the cosmic glue and glitter, there are a few things you'll need to consider. Let's start our ultimate DIY project. First of all, we need to choose a location. Every planet has to orbit a star, right? In a cosmic buffet, every star has its own unique flavor. To keep things organized, astronomers use the so-called stellar classification system. The massive stars are the divas of the cosmos. They're huge, bright, and are always stealing the spotlight. But it's not all sunshine and rainbows. They have a short lifespan, burning out super fast, like a candle. They also have huge gravity, so be careful that your planet doesn't get sucked in. The dwarf stars, on the other hand, may be small, but they make up for it with their stamina. They can burn for trillions of years, which means that their planets have plenty of time to develop life. Super hot stars are blue or white ones, while the cold stars are usually red or orange. Yeah, seems like it should be the other way around, but we're not the ones making the rules. So what do we choose? Well, the planets around the blue and white stars could be scorched and fried, like a crispy chicken nugget. On the other hand, with cool red stars, our planet may turn into an ice ball. If that's your preference, then sure. But you can always pick a nice middle ground, a yellow star like our sun, for example. Not too cold, not too hot, but just right. Now that you've picked the star, let's start building the planet. The heart of the planet is its core. The core creates a magnetic field, an invisible force that protects a planet from harsh cosmic rays and charged particles. If it weren't for this field, the planet would be fried by the star's radiation, like a well-done burger. But the magnetic field isn't always a force for good. On some planets, like Jupiter, it's so strong that it creates super intense radiation belts and some crazy weather. If you were hoping to use a compass to find your way around on such a planet, forget it. The magnetic field would have the needle spinning like a breakdancer on caffeine. So, if you pick a small light core, the planet will have less protection from solar radiation, like tanning without sunscreen. On the other hand, larger cores can generate more heat, which can lead to more volcanic activity and earthquakes. The best option is a medium-sized core made mostly of iron and nickel, enough to keep the bad things away, but not too strong to turn a planet into a cosmic hot potato. Once the heart is in place, we can move on to the next step. Planets are like onions. They have layers. Most planets have three main layers: the core, the crust, and the mantle. The core is the filling, as we've already discussed. The mantle is like a hot and gooey layer of caramel between the crust and the core. And the crust is like a thin layer of icing on a planetary cake, covering its surface. But not all planets are built the same way. Because of that, we have tons of options. First up, we have the gas giants, the big boys of the universe. In our solar system, it's Jupiter and Saturn. They don't have a crust at all. They're basically huge balls of gas, like hydrogen and helium, hence the name. Next, we have the ice giants, like Uranus and Neptune. They're like younger, cooler siblings of gas giants. These planets don't really have a solid surface, but it's not pure gas either. They're made mostly of water, ammonia, and methane ice. There are also ocean worlds, and no, they aren't made of pure water. They do have some kind of solid surface, but it's located so deep, and the ocean on their surface is so huge that it kinda does look like a giant water drop. Finally, we have terrestrial planets, like the Earth. They're made mostly of rock and metal. These planets have a surface to stand on, and usually come with a cool mineral collection. And let's not forget about the dwarf planets, the small but mighty. Pluto is probably the most famous one, but there are others in our solar system: Eris, Ceres, Haumea, and so on. They're the scrappy underdogs of the planetary world, always trying to prove their worth, but never making it to full-fledged planets. Which type do you like the most? Gas giants are probably the coolest ones with their enormous sizes, crazy winds, and scary lightning. We also need to create an atmosphere. It's the outer layer of a planet that plays a huge role in its climate and weather. It's also the planet's ultimate protector. Did you know that 90 to 95% of meteors burn up in the Earth's atmosphere? Imagine what would happen if they didn't. Dense and hazy atmospheres, the ones you'll find on places like Venus, have thick layers of carbon dioxide and sulfuric acid. In other words, it's not a planet, but an oven. It's so hot that you could cook a pizza on its surface in no time and get cooked yourself. Next, we have thin and wispy atmospheres, like on Mars. The thin layer of carbon dioxide makes its surface pressure about 1% that of Earth's. On planets like these, you could fly like a superhero if you had a good enough jetpack. Then we have mixed atmospheres, like the one on Earth. The layers of nitrogen, oxygen, and other gases create the perfect conditions for life as we know it. It's also where we get to enjoy sunny days, rainbows, and of course, water. And last but not least, exotic atmospheres. You'll find them on planets like Neptune, where the layers of hydrogen, helium, and methane create a blue-colored world that looks like a giant marble. They're super weird and unusual, so just perfect for creative planet builders. Almost done. The final question is, would you like your planet to have life on it? In that case, there are some things you should consider. For example, it should be located in the habitable zone. This is the sweet spot around a star where conditions are just right for liquid water to exist on the surface. Make sure your planet isn't too close or too far from its star. And don't forget about the temperatures. For example, you'll want a good amount of oxygen for a planet to be nice and warm, but not too much that everything spontaneously combusts. Of course, we need some water, but not too much, and a stable climate. You don't want your planet to be going through extreme swings in temperature or moisture. That's a recipe for extinction, not evolution. Oh, and the orbit should be stable, so that there are no major astronomical events that could throw things off. As you can see, this type of planet is very picky. No wonder it's so hard to find extraterrestrial life. Anyway, now that we've finished messing around in the Planet Creation Editor, how do we even build it? Well, how about terraforming? It's when we deliberately alter a planet's atmosphere, temperature, and other conditions to make it habitable for humans and other Earth-based life forms. For example, we could release greenhouse gases on Mars to warm up the planet and create a thicker atmosphere. But this method is more like polishing a monstrosity that was given to you by a character randomizer. What about building from scratch? That's something straight out of sci-fi. But maybe in the future, we could do that, using large-scale 3D printing or nanotechnology. We could create the basic structure and then add all the necessary conditions for life to exist. Of course, all this is still purely theoretical. But while creating a planet artificially is still a long way off, there are many creative ideas and concepts being explored by scientists and sci-fi writers. Who knows what the future might hold for the possibility of creating new worlds?
The Hubble telescope orbits our planet, looking out at the big unknown universe. Since it's out of our atmosphere, the Hubble can see way further than telescopes on land. No clouds up there. This guy helped us confirm the theory about supermassive black holes in the center of galaxies. It also discovered a whole bunch of new galaxies, including the world's oldest one, which is about 8 billion years older than our own. But let's travel 25 light-years away to another special star, Fomalhaut. It's one of the brightest stars in the night sky, and it's in the constellation Southern Fish. It's almost twice as big and heavy as the Sun. If you look at it from far away, you can see a bright yellow disk around it. It's a debris disk full of bits of space rock, and it's huge. Its width is about 25 times the distance from the Earth to the Sun. Scientists were curious about it. Was all this space dust going to get smushed together and become a planet one day? But then they saw something else. Right there, through all that debris, was a massive, mysterious object. A large yellow dot orbiting the star. It looked like it was skating around a cosmic ice rink. So, in 2008, scientists announced they had discovered an exoplanet called Fomalhaut b. It was the first planet outside of our solar system that we could actually see with our own eyes. It's hard to know how heavy it is, probably like a couple of Marses put together, and it lives pretty far from its host star, about 4 times the distance from the Sun to Neptune. 1 year on the planet would be the same as 1,700 Earth years. We'd all be babies over there. So, one question. Does the planet even really exist? Scientists sat around arguing about it. Then, in 2012, the trusty Hubble telescope came up with some new data. It was real all along. If it was a gas giant like Jupiter or Saturn, that would make it incredibly young, 10 times younger than Earth. And all that dust around it seems to shine non-stop. You'd have to wear sunglasses 24/7. But now, it's disappeared again. Nothing but a donut of debris. So, maybe it was destroyed by a giant asteroid, like the one that wiped the dinosaurs off the face of the Earth. Or it may have been crushed by a rogue planet. These are planets that fly around the galaxy without a clear orbit. Maybe the dust is all that's left from a head-on collision. Or maybe something went crazy in the planet's core, and it exploded from within. Scientists now believe that Fomalhaut b was never actually a planet in the first place. It was just the leftovers of two big rocks smashing together. From far away, that kind of massive collision would actually just look like a yellow dot. These two colliding space rocks must have been at least 125 miles wide. That's like DC to Philadelphia wide. But this isn't the first time a planet's just up and disappeared from view. Scientists thought they'd found an Earth-sized planet orbiting our neighbor, Alpha Centauri. They called it Alpha Centauri BB, not exactly flashy. Plus, in the end, it turned out it didn't exist. Oops. Scientists make mistakes, just like the rest of us. Not long ago, they thought there might be life on Venus. They found traces of a special gas, phosphine, which can be a sign of life. It was the top story for a month. But then, someone decided to double-check the data. There was some phosphine floating around, but not nearly as much as they thought. Travel back in time a couple of hundred years, and you can find even sillier mistakes. Back then, people believed that the sun revolved around the Earth, and that our planet was the center of the whole universe. That's because they didn't have fancy equipment to measure stuff. People saw the sun rise in the east and set in the west. That was enough to say that the sun revolved around us. So, what happened to that planet? Basically, the Hubble took a photo of the whole star system, but since it's so far away, the photo came out kind of blurry. Scientists just saw a large yellow dot and assumed it was a planet. Scientists don't usually get photos of far-off planets. They normally have to use math to find them. Space objects are in a constant dance with one another. The dance gives off a lot of energy, like gravitational energy and light energy. It's like this. Say your friend is hiding behind a corner. You can't see him, but you can see his shadow on the floor. It's kind of like what scientists do when they look out into the stars searching for planets. So, big deal, a planet vanished billions of miles from here. But what if our perfectly balanced solar system were to lose one of its planets? You better believe it would affect our lives. Mercury's up first. Good news, it's too small to have a gravitational effect on our planet, so we wouldn't even notice if it went missing. Next in line is Venus. This hot planet is sometimes called Earth's twin sister. It's completely uninhabited, of course. Other than that, Venus is one of the brightest spots in our night sky. Pull it out of the solar system and whoa, it's much darker at night. But still, not exactly a big deal. Mars. Life without Mars might even be good for the Earth. There's an asteroid belt between Mars and Jupiter. Mars's gravity can grab an asteroid from the belt, spin it around, and catapult it toward us. Without Mars, the asteroids would stay in place thanks to Jupiter's gravity. Jupiter's heavier than all the planets in our solar system combined. It holds back the asteroid belt, and its gravity is actually strong enough to affect the Earth. A couple of thousand years after it disappears, we'd notice big changes. We'd move closer to the sun, which means a couple of things. 1, we'd have much hotter weather all year round, and 2, our days, weeks, and years would be shorter. Saturn, Uranus, and Neptune are all too far away for us to notice if they go missing. That just leaves one. No, not Pluto. What if the moon disappeared? Basically, chaos. The Earth would tilt even more than it already does, and the weather worldwide would go crazy, even crazier than now. It might even lead to a new ice age. The Earth would start spinning a lot faster, so instead of 24 hours in a day, we might have anywhere between 6 to 12. And even though nights would be a whole lot shorter, they'd also be darker than ever. When we see the moon, we're actually seeing the sun reflecting its light off the moon. And even a new moon is usually the brightest object in the night sky. If the sun were to disappear from our sky, it would be pretty much game over. This star is the center of our whole solar system. Without it, the orbits of all the planets would collapse, and we'd move around in complete chaos. The Earth, the Moon, and all the other neighboring planets would just shoot out into the universe, heading for, well, we just don't know. Daytime would be a thing of the past. We'd need the sun for that. So it would be nighttime forever. We'd probably never see the moon again. We'd probably never see anything again. the Earth would get colder and colder, and all the water on the planet would gradually freeze. But what if the Sun turned into a black hole? We might still orbit around it. Hopefully, we're far enough away from it to stay safe. Mercury and Venus might be swallowed up, but we might get lucky. So we'd stay where we are, but we wouldn't have the Sun to warm us. If it happened slowly enough, we might be able to adapt. We'd need a new power source, a new light source, and plants would have to adapt to get their energy from somewhere else. We'd probably need to build a huge tent-like thing over every city, forest, ocean, or we might just jump ship and move to another planet. Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new superplanet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up. It's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the north and south poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars. But because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient. Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214. An unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's Great Red Spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the near future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level parallel to the ground so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be on edge in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought.
They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mentioned the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 300 to 400 mile-per-hour jet streams. But like any other storm, the Great Red can't keep raging forever. It's been shrinking for a long time. In a decade or two, it's predicted to turn into GRC, the Great Red Circle, and who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 35,000 miles across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 10,150 miles, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet sitting over 3 billion miles away from Earth in the region of the Kuiper Belt drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving further away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects, just like the sun, they were still sure that stars went through major changes extremely slowly, on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they're hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggest that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate. But VASCO is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs, and neutron stars or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and its and our future.
Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's north polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today.
The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show.
And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases! Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during this second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And according to the second law, these tiny invisible particles make up everything from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
What do you mean by saying that there will be a little device in your pocket with all the knowledge of the world? People will be able to communicate with one another from any place on the globe at any time. And many machines will get artificial intelligence? Sorry, my friend, I can't believe this. It all sounds like a fairy tale. Perhaps that's how people from 1923 would have reacted if someone had told them how technology would change in 100 years. But how would we react if somebody from the future went back in time and told us about 2123? We don't need a time traveler to find this out because modern scientists can already predict how technology will develop in the next few decades. So let's start with the most essential thing: medicine. Research, diagnostics, treatment methods, all these will develop quickly. Doctors and chemists of the future will be doing their job along with AI assistants. They will be able to diagnose and treat diseases much faster and more efficiently. There will be nanotechnology that can cure severe health problems without surgery. Imagine millions of tiny robots getting into your body to handle all your problems. But along with this, new dangerous bacteria may appear in the world that will be difficult to cure. Nature and evolution always keep a balance. On the one hand, our medicine will defeat bad microorganisms, but on the other hand, it will only make them stronger. People will get huge health upgrades. It's possible that we will be able to defeat aging in a few decades, living for 200, 300, 500 years. All this can become a reality. Some people living today will probably regain their youth in the next 100 years. Pharmaceutical companies will create tools to improve memory and mindfulness. The most powerful machine in the world, that is, our brain, will become even stronger. Muscle and fat-burning tonics can turn a dream into reality. Imagine a device that trains your muscles while you sit on the couch and watch dinosaurs running in your yard through the window. Only it's not a window, but a TV that gives 20K image quality indistinguishable from reality. Integrating technology into human anatomy will completely change the appearance of people. How about digital tattoos or lenses with infrared vision that can change your eye color? Flash drives in your brain to store all the information from a video tutorial. Metal bones and super strong muscles. Energy. We may completely switch from lithium to solar batteries in the next 100 years. Imagine thousands of large satellites with solar panels flying around the planet and providing Earth with unlimited energy. We will also be able to get a lot of energy from wind and water, and all this will allow us to make discoveries faster and more efficiently. With the help of light energy, we will study the universe much better and possibly find extraterrestrial life. A research project called Breakthrough Starshot is already in development. Scientists and engineers are creating ultra-fast nanocrafts powered by light. These are tiny robotic probes that have various research tools and communication systems. Thanks to their size and speed, they will be able to reach the neighboring Alpha Centauri star system in 20 years. Modern spaceships will reach this point only in 76,000 years. Nanocrafts will allow us to study exoplanets not through telescopes but from up close. We will be able to see videos of these new worlds, explore their atmosphere, and find living organisms. If they are there, of course. But most importantly, we will understand which of these worlds are ideal for humanity. By that time, the colonization of planets will not be new to us because, within 100 years, we will surely send the first people to Mars. We will study its atmosphere, find sources of fresh water, build houses, and create a transport system. We will start bringing more and more products from Earth to the Red Planet and develop the economy between settlements on Mars. People will live in small communes under large domes where they can breathe without a spacesuit. The development of extraterrestrial technologies will significantly improve our economy and create many new jobs. Maybe we'll find some valuable material on Mars and start spending billions of dollars to mine it. Our gadgets and laptops will become powerful computing machines thanks to quantum computers. It will likely be the most profound revolution in the world of technology, even more marvelous than the invention of the internet. The internet is just a huge platform where we share information and knowledge with each other. But the quantum computer will give us more.
It will be able to do things that the most powerful supercomputers today can't even come close to. Calculations for space travel, genetics, chemistry, and physics. Currently, people are building large farms to mine Bitcoin. One quantum computer may be able to do this 1,000 times faster. Combining quantum technologies and artificial intelligence will contribute to the technological singularity. This is a level of development when the speed of technological invention accelerates and progress becomes uncontrollable. People lived for several thousand years using the same technologies, and then, in the last 100+ years, everything changed. Thanks to electricity, the internal combustion engine, penicillin, and other discoveries, we could create antibiotics, cars, the internet, cameras, video games, and thousands of other things. And all this in a very short period. In a sense, this was also a technological singularity. So, quantum computers and artificial intelligence will be the next booster, like the Industrial Revolution before, thanks to which the world will begin to change every day. Virtual reality glasses will become archaic in the future. People will wear transparent lenses with a digital interface or install chips in their brains. Scientists will be able to recreate the DNA of dinosaurs and mammoths. There may be technologies for recording dreams. Predicting the development of progress after a technological singularity is quite difficult. The human brain may not adapt to these rapid changes, which can lead to serious mental problems. Today, spending many hours watching short videos on social networks puts a lot of pressure on the brain. What will happen next when virtual reality becomes as real as ours? A simulation of the perfect world will draw many users away from real life. Our perception of the world works thanks to the brain, which processes signals through our senses. For example, music enters our ears, where the eardrum receives sound waves, then transmits them through a special channel in the form of a signal. And then, these signals reach the brain, which turns them into the sounds of music. Now imagine that these waves can be sent to the brain simply by stimulating its neurons with an electric current. You will hear music that doesn't really exist. So in the future, virtual reality headsets may appear. They will stimulate millions of brain neurons responsible not only for sounds, but also for smells, touch, and vision. There will be no difference between real life and virtual life for you. Let's hope that people will venture out from there to at least drive flying cars. In the future, they will be as ordinary as modern vehicles. You will be able to travel long distances with the help of the Hyperloop trains moving inside vacuum tubes at the speed of sound. Going on vacation to space stations or Mars will be as cheap as traveling to another country today. Thanks to the growing competition and lowering prices, cool technologies will be available to everyone. Remember how it was with cars in the 20th century? Only the richest had them. But after a few decades, ordinary people with average incomes started buying beautiful vehicles. Even if you can't buy a flying machine in the future, you'll be able to take a ride in a sky taxi. People will have to study constantly to keep up with the technologies. Not everyone will withstand this stress. Artificial intelligence will render millions of people around the world jobless. But in the end, all this will benefit us because there's no progress and development without overcoming difficulties.